Okay, so now we complete to calculate the confidence interval. So we have all the information. We have T alpha over 2 and V, which is 1.833. We have the X bar, the sample mean, to be 0.738. We have the sample standard deviation 0.0358. We have the sample size to be 10 elements. Also, we have the hypothesized mean or mu naught to be 0.75. So to use the confidence interval, we use the two-sided confidence interval because we are testing on two-sided hypothesis. So this is the high confidence interval, the same as we have seen before in the normal distribution or when we know the population variance. We have replaced the sigma with S. Also have replaced the Z with T alpha over 2 and V. So we have all the information. Now we are going to substitute by the values, and finally we get the confidence interval to be mu lies between 0.7142 and below 0.7636. So what next? If we look for the mu naught is 0.75. So 0.75 actually is included or lies inside the confidence interval. So because mu naught lies inside the confidence interval, we are going to fail to reject the null hypothesis, which is the same conclusion as we have found using the test statistic. So another method, in fact, is to use the p-value. So in fact, from the t distribution table, it is approximately impossible to calculate the exact value of p-value, but we are going to have some kind of estimation or approximation for the p-value. So the p-value for the two-sided test is the summation of probability above t0 and below minus absolute value of t0. So now we know that t0 is minus 1.06, but we know also the t distribution is symmetric, so we can use the positive side of the t distribution. So we look for the 1.06. So 1.06 lies between these two values. We choose this row because we have the degree of freedom to be 9, which is 10 minus 1. We have 9 degrees of freedom. So we look for the value 1.06 lies between which any values. So 1.06 lies between 0.703 and 1.383. So the value of t0 lies in between here. So we know that the p-value will be something like larger than 2 of this and below than 2 multiplied by this value. We use the 2 multiplier because we have two-sided. We have one side to the right and one side to the left. So we conclude that the p-value is larger than 2 multiplied by 0.1. Here is the value 0.1. So the p-value is larger than 0.2. So we are going to reject the null hypothesis only in case the p-value is less than alpha. But we know that alpha is 0.1 and p-value is larger than 0.2. So our conclusion is we fail to reject the null hypothesis because the p-value is larger than alpha. Because p-value is larger than 0.2 and alpha is only 0.1. So for the p-value, we have noticed that we could not compute the exact value of the p-value from the t-distribution table directly. So instead we can use some software such as Minitab to get the exact value of p-value, and later we will see how to use Minitab to calculate the p-value. So using the Minitab software, we have calculated the p-value to be exactly as 0.317, which is larger than alpha, So finally we are going to fail to reject the null hypothesis. Finally we are going to have a look for the large sample size. So if we have a large sample size, for example 30 elements in a sample or 40 or more, we can either use the t-distribution or the normal distribution as before. So we can use t-naught statistic or z-naught test statistic. And finally we are going to approximately have the same result. In fact, this happens because when the degree of freedom is larger and larger, the t-distribution approximately come like a normal distribution. In fact, later we will see also an example for the large sample size.